Yeah, good morning, everybody. Happy Friday. This is the last day before you go to spring break. Okay. Now remember, you're going to have all of next week off, and you're going to have the Monday and Tuesday of the following week off. Now, when you come back on that following Wednesday, March 31st, that Wednesday, Thursday, Friday, March 31st, April Fool's Day, and April 2nd are all going to be asynchronous as us teachers prepare to bring you back in real life. Send your teachers emails if you have questions that you're concerned about, and hope to see you in person soon. All right, exciting. Anyway, copy this down. This is a little bit of a test for you. These are all things that we've covered this year, and we want to see if you know how to do them. Okay. So here, if you can't read my writing, what are the words to describe the numbers that go in these four spots? Okay, and your choices are factors or add-ins, product or sum. Then see if you can solve these two diamonds. Okay, see if you can solve these two exponents. They are not equal. And think to yourself, what is another way of saying to the second power? Okay, so if you had like 5 to the second power, is there another way of saying that besides the answer? Okay, what are these things called? And what are these things called? And can you solve them? Okay, do this long division problem. Use a generic rectangle to find the answer to 386 times 42, and then prove it using the standard algorithm. Do you know how to do both? Okay, try it. This is a good test. Multiply these decimals, add these fractions, subtract these mixed numbers, multiply these fractions, multiply these mixed numbers, divide these fractions, and get the area of these three shapes. I did not throw a trapezoid in there for you. All right, pause it, copy it, see how you do. This is a good check. It's for fun. It's to warm us up, and we will see in a bit. And your bit is up. Let's go. What are the words to describe the numbers that goes here? Well, this is the product. The product goes on top. Remember what that is? That's the answer to a multiplication problem. The sum goes on the bottom. That's the answer to an addition problem. And two numbers that you multiply to get a product are called factors. Okay. And two numbers you add to get a sum are called add-ins. This kind of makes sense, right? But it's good to know those words. They come up, and it's just the language of math. Okay, so how would you do in that so far? All right, how about this one? Were you able to solve this first time? Okay, hopefully you got 4 times 5 is 20, 4 plus 5 is 9, or 5 and 4 works, right? And on this one, hopefully you got 5 times 20 equals 100. 5 plus 20 is 25. 3 to the fourth power is not 12. It's 3 times 3 times 3 times 3. Okay, and you can go in order and say 3 times 3 is 9, 9 times 3 is 27, or you can say 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81, 3 times 27 is 81. Same answer. Here you're going 4 times 4 times 4. It's not 20, it's not 12. Why did I say 20? Because sometimes people get that first 4 times 4 is 16, and then they add that last 4. 16 times 4 is 64. Another way of saying to the second power is to say squared. And we're starting to figure out why, right? If I had a square and each side was 5, the area would be 5 times 5. 5 to the second power, 5 times 5 is 25. The area of the square is 25 square units. What is this called here? This is called absolute value. Okay, and another way of looking at it is how far is that number from 0? Well, how far is negative 3 from 0? 3 spots. Absolute value of negative 3 is 3. How far is 3 from 0? 3 spots. The absolute value of 3 is 3. How far is negative 5 from 0? 5 spots. But I still have that minus sign, right? Anything outside is not going to get erased. Okay, you saw what's inside the absolute value bars. So 3 plus 3 is 6, plus negative 5. I have 6 plus I owe 5. I'm going to pay the 5 I owe and still have 1 left over. What is this? This is the square root of 36. And again, you have a square and you say the area is 36. What's each side? 6. All right, what number squared is 36? 6. What number squared is 100? It's not 50. What number times itself? That's going to be 10. Okay, long division on the 3 into 846. Let's write it over here. Give ourselves a little bit of room. 8, 4, 6. Now 3 goes into 8 how many times? Twice. Now I go 2 times 3 is 6. I subtract. What do I do when I get an answer to subtraction? I bring down the next number. And 3 goes into 24 how many times? 8. 8 times 3 is 24. So when I subtract, I get a 0. What do? Bring down the next number. And 3 goes into 6 twice. 2 times 3 is 6. Perfect. No remainder. 282. Okay. Now, generic rectangle, 386 times 42. Let's do that on the back. Okay, so I got 3 digits times 2 digits, right? So I'm going to have 3 hundreds because that's 300. 80 is 8 tens, right? And 6 ones. And here I just have 2 digits. I have 40 and 2. 4 times 3 is 12, but I'm going to move the decimal over 1, 2, 3 spots for those 3 zeros, 12,000. 4 times 8 is 32, and now I got to move it over 2 spots. 4 times 6 is 24, move it over 1 spot. 2 times 300 is 600. 2 times 80 is 160, and 2 times 6 is 12. So I got to go add all these. 12,000, 3,000, 200, 240, 600, 160, and 12. Add them all up. I got a 2. I got 11. So I'm going to carry the 1. 1, 2, and 2 is 5. 6 is 11. 12. Carry the 1, and that's going to be 6. So 16,212. Now to prove it using the standard algorithm, we line up the ones place, and we start multiplying. 2 times 6 is 12. Carry the 1. 2 times 8 is 16 plus 1, 17. Carry the 1. 2 times 3 is 6 plus 1, 7. Now I'm going to put a placeholder because that 4 is really 40. And I'm going to cross out these marks for when I carried so I don't get confused with the next group. 4 times 6 is 24. I put the 4 there, carry the 2 above the 8. 4 times 8 is 32 plus 2 more is 34. Carry the 3. And 4 times 3 is 12 plus 3 more, 15. Now I add them. And I get 16,212, same answer. So I'm pretty sure I did it right. Okay, 2 different ways. 16,212. You'd think I'd remember that. It took about 10 seconds, huh? Okay. The next problem is multiplying decimals. And the key to multiplying decimals, the first step is pretend there's no decimal. So instead of 4 hundredths times 6 and 23 hundredths, I'm just saying 4 times 623. 4 times 3 is 12. Carry the 1. 4 times 2 is 8. Plus 1 is 9. 4 times 6 is 24. Now I go back, and to pretend that was a 4, I had to move the decimal 2 spots. To pretend that was 623, I had to move the decimal 2 spots. That's a total of 4 spots I had to move my decimal. So I have to go back 4 spots in my answer. So my answer is 0.2492. Now, why did I put a 0 in front of that? If you start a number with a decimal, sometimes it gets lost. And if you start a number with a 0, you say, why are you doing that? That really sticks out. So it's a good way of really bringing that decimal to the eye of the reader, which is what you want. You want them to notice that decimal. Okay? So it equals the same thing. It's just a better way of writing it, I think. 4 sevenths plus 2 fifths. You cannot add sevenths and fifths. Why? They have different denominators. It's like adding pesos and dollars, right? You have to change the pesos to dollars or the dollars to pesos, or both of them to like Japanese yen or euros or something, right? Easiest way to find a number they both go into those denominators is to multiply them. 5 times 7 is 35. I'm going to change these to 35ths. Now I did 7 times 5 to get that 35, so I have to go 4 times 5 to get the equivalent fraction, right? That way I'm multiplying it by 5 over 5, which is 1, the magic 1. Remember that? 5 times 7 to get 35, so I go 2 times 7. Now, what's a common mistake there? People will do 7 times 5, and then they put a 5 there instead of 4 times 5, right? They do 5 times 7, they put a 7 there instead of 2 times 7, okay? So I have 20 35ths plus 14 35ths. That's a total of 34 35ths. That's pretty close to 1 whole. Oh, can't get much closer. Okay, subtracting mixed numbers. Okay, and I'm going to have to borrow here. 18 and 2/9, 3 and 2/5. I stack them. All right, why do I do that? Because I'm pretty sure I'm going to have to change denominators, and it allows me. Okay, so the 18 and the 3 are going to be there, right? But what's my fraction? Well, 9 times 5 is 45. So I'm going to say 45ths here. Okay, and I did 9 times 5, so I go 2 times 5. 2/9 is the same as 10 45ths. Excuse me. And 5 times 9, I got to go 2 times 9. 2/5 is the same as 18 45ths. So here I am trying to take 18 45ths away from 10 45ths. I can't do that, can I? So do you remember what you're supposed to do? Okay, I got to borrow. I got to get some more 45ths from this 18. So I'm going to call that 17. I'm borrowing 1 whole. Don't go put a 1 in front of that, because then you're adding 100 45ths for that 1 whole. 1 whole is not equal to 100 45ths. Not equal, right? How many 45ths is equals 1 whole? 45, right? So I'm saying I get 45 more 45ths. Now I got to, don't forget to add that to the 10 that you already had. Okay, I had 10, I borrowed 45 more. Now I have 55, and I could subtract 18 from 55. Now sometimes you got to come over here and do the borrowing here. All right, 15 minus 8 is 7, 4 minus 1. So 37 45ths. And now I have 17 instead of 18 minus 3. 14 and 37 45ths. And I always say, these are some of the hardest problems you do in 6th grade. When you are subtracting mixed numbers with unlike denominators and you have to borrow. That's a lot to even say, more or less do. So if you got that right, take a time out. Pat yourself on the back. Ring the cowbell. Plug your ears, Micah. Good job. All right, on to the next one. 3/8 times 1/5 multiplying fractions is what? Hopefully you know that's easy. Why? No common denominator stuff. 3 times 1 is 3. 8 times 5 is 40. Boom. Sometimes you have to simplify. That one you don't. You're done. You're like, oh, slipped an easy one in there, Mr. Daniel. What's wrong with you? 2 and 1/5 times 3 and 2/3. All right, so different ways of doing this. Some people like the generic rectangle. 2 1/5, 3 2/3. They multiply the 4 they add. I like using the C method and just turning these into fractions, right? Remember how you do this? 5 times 2 is 10 plus 1, 11. 11/5. 3 times 2 is 9 plus 2, 11/3. Now I go straight across the top. 11 times 11, 121. 5 times 3 is 15. Now I have to divide 15 into 120, and that's almost a perfect fit because 15 goes into 120 perfectly. 121, not quite. Okay, how many times? Well, turns out 8 times 15 is 120. Okay, now sometimes you got to come over here and you got to try things out. You got to go multiply, right, and see how close did I get. Okay, boom. All right, sometimes you did 7, sometimes you did 9. You had to adjust it. Now, what do I do with my remainder? My remainder comes on top. My divides are on the bottom. Okay, 8 and 1/15 on that one. Okay, and you could prove it doing that one, but this warm-up's already at 15 minutes, so we're going to hurry up and go through it. Now, what do we do here? Smell my feet. Leave the first number the same. 8 and 9 stays the same. Don't mess with it. It's easier if you leave it the same anyway. I'm going to multiply instead of divide. Why? Because multiplying fractions is easy. And then the F, instead of feet, you're saying flip. Instead of 2 over 3, I'm saying 3 over 2. Now, when I get 24 over 18, I can simplify that because 6 goes into the top and bottom. 4/3 is 1 and 1/3. Okay. Now, on this one, you had to either change this to a decimal or change this to a fraction. I'm going to change this to a decimal because I know that 3/4 is 75 cents. And I'm multiplying 12 times 75. And I get 900, but I'm going to move it over 1, 2, 3 spots. 9, and it's going to be square units. Area of a parallelogram is how wide it is times how tall, so you don't care about that 14. What's 6 times 11? 66 inch times inch equals inch squared, inch to the second power. I don't care about this 10 or this 10. I care about 1/2 times the base times the height, right? If you got 80 square feet, you got the most popular wrong answer. All right, it's half of 80 or 40 square feet. Now, you can do that by going 10 times 8, getting 80 and taking half of it, 40. You can also say half of 10 is 5 and 5 times 8 is 40. You can say half of 8 is 4 and 4 times 10 is 40. Okay, how'd you do? Okay, if you got all these right, you are acing 6th grade right now. Keep up the good work. Okay, we will see you on the other side, is what they say.